This section is going to talk about absolute value inequalities. So before we talk about absolute value inequalities, it's important to remember the definition of absolute value. So the definition, if you recall, is the distance from 0 to any number. So for example, if we said the absolute value of x equals to 3, we want to figure out which numbers are exactly 3 spaces away from 0. Okay, so if you were to sketch this on a graph, this is 0. Which numbers are 3 spaces away from 0? Well, that's 3 and negative 3. So x would equal to 3 and x would equal to negative 3. Okay, so we have exactly 2 numbers that are 3 spaces away from 0. But what if we change this? So in your first little arrow thing, we have this. We have the absolute value of x is greater than 3. So I want you to understand what this is asking. Okay, so this is the distance from 0 to a number. We're saying for which numbers, for which values of x is the distance greater than 3 from 0. So for which values of x is the distance from 0 to that number greater than 3. Alright, well, here it's exactly 3, at 3 and negative 3. We want that distance to be greater than 3. So for example, if you look at x equals 4, the absolute value of 4, that's greater than 3. Because 4 is more than 3 spaces away from 0. Okay, so again, what this question is asking is which numbers are more than 3 spaces away from 0. This is the distance from 0 to a number. So for which numbers is the distance more than 3 from 0? So for any number that's bigger than 3, like 4 or even 3.1, 3.2, all these numbers are more than 3 spaces away from 0. But same thing happens on this side. So if you look at a number like negative 4, the absolute value of negative 4, that's 4, that is also greater than 3. Okay? Because negative 4 is more than 3 spaces away from 0. So that's what we're asking. We're asking which numbers are more than 3 spaces away from 0. So like negative 4, negative 5. In fact, any number to the left of negative 3 is going to be more than 3 spaces away from 0. So anything to the right of 3 and anything to the left of negative 3 is more than 3 spaces away from 0. If you look at something like negative 2, that's 2 spaces away from 0, so that doesn't count because we want it to be more than 3 spaces away from 0. How do we graph? How do we write this in interval notation? Well, or let's just talk about an inequality. So this represents all the numbers that are less than negative 3. Or you can also have numbers that are greater than 3. So for x less than negative 3 or x greater than 3, all these are more than 3 spaces away from 0. Now let's convert this to interval notation. If you have x less than negative 3, the x's are getting smaller and smaller and smaller. So the low point is negative infinity and the high point is negative 3 with the parentheses. Now the word or, anytime you have 2 disjoint sets that are part of the solution, we join them with a u. This is a union. We join them with a u. And then here, it's going to be 3 to infinity. It starts at 3, numbers get bigger and bigger and bigger, it goes to infinity. Okay, so x less than negative 3 or x greater than positive 3. There's a really easy way to remember, or actually you don't have to remember, you just have to follow the rule. If you have any inequality that is absolute value, here's what you do. You keep the original inequality, so that's x greater than 3. Then you flip the inequality and you flip the sign. So that gives you x less than negative 3. You flip the sign, you flip the inequality, you change the sign from a 3 to a negative 3, and those become your 2 inequalities. Okay? But I want you to understand, this is asking which numbers are more than 3 spaces away from 0. Alright. Let's do another problem. What if we had this? What if we had the absolute value of x is less than 5? Okay, so now we're asking the opposite question. We're asking which numbers are less than 5 spaces away from 0. Okay, so on a number line, here's 0. I know because I have absolute value, 5 and negative 5 are somehow going to be involved. Okay, now let's take a number like 6. That's 6 spaces away from 0. So that's not going to work for our solution because the absolute value of 6 is not less than 5. That's a false statement. So 6 is not going to work. We want the distance to be less than 5. So what's going to work? Like 4 is going to work, 3 is going to work. All these numbers are less than 5 spaces away from 0. Okay, so on one side, we can go from 0 to 5. Well, we got to stop there because if you go past 5, then it's no longer less than 5 spaces from 0. Same thing on the other side. We can go to -5 because -1, -2, -3, -4, all of these numbers are less than 5 spaces away from 0. Okay, so this becomes your solution set. Okay, now how do you write this? So the way you write this is the following. In interval notation, well, okay, first let's talk about the inequality. The rule that I gave you guys here is you write the original inequality, which is x less than 5. And then you flip the inequality, so make it greater than, and you flip the sign, so the 5 becomes a -5. So x is greater than -5, and at the same time, x is less than 5. So here's what happens. This is called an intersection. So this is a union because you got two disjoint sets. Here we have just one solution set. We don't have two different directions. They meet in the middle. So this is called an intersection. An intersection is given by the flipped U. That looks like this. Intersection means on one side you have numbers that are getting bigger than -5. On the other side you have numbers that are less than 5. So the solution, it meets in the middle. Because you have to be bigger than -5 and at the same time you have to be less than +5. So you meet in the middle. And the way you write that in interval notation is the low point of your solution set is -5. The high point is +5. So this will be your interval notation. In general, for greater than, you're going to get a union because you have two different sets. For less than, you want numbers to be less than 5 on this side and less than -5 on this side. So you're going to get an intersection, which you write like this. Okay? So, here's what your notes say. To solve absolute value inequalities, first you isolate the inequality, that's important. You write the original inequality and solve. So you write the original inequality, write the original inequality. Then you flip the inequality, change the sign. So flip the inequality, change the sign. Same thing, same rule works in both cases. You graph the solution. So you graph it because you want to figure out, do we have a union or do we have an intersection? Once you graph the solution, it'll tell you if it's a union or intersection, and then you just write the solution in interval notation. Okay? So let's do an example and go through all the steps. So here's your first example. So the first example says, we have the absolute value of x minus 6 greater than or equal to 8. Okay, so again, we want to figure out for which values of x is the distance greater than or equal to 8, more than 8. So like 9, 10, 11, etc., etc. Okay, the distance has to be more than 8. So let's follow the rule. Rule 0 says isolate the inequality, that's done. First step, write the original inequality itself. So the original inequality is x minus 6 has to be greater than or equal to 8. So if I solve that, if I add 6 to each side, that's going to give me x greater than or equal to 14. Okay, now the other way, you flip the inequality and change the sign. So we're going to get x minus 6 less than or equal to -8. Flip the inequality, change the sign. If I add 2 to each side, or if I add 6 to each side, sorry, we're going to get x less than or equal to -2. Now, you might be able to tell if it's a union or intersection, you might not. So you graph the solution. So x less than or equal to -2, what does that look like? This is -2, and since the values of x are getting smaller and smaller, it's less than -2, we're going to shade it going to the left. The other way, you got x greater than or equal to 14, so this is 14. Greater than means the numbers are getting bigger and bigger, so we're going to shade going that way. Is that an intersection or a union? Well, we have two disjoint sets. We have two different sets, one going to infinity, one going to negative infinity. They don't ever meet. So because they don't meet, it's a union. How do you write this? The left is going to be negative infinity, comma, negative 2. The low point is negative infinity, high point is negative 2, and there should be a bracket. We have a gap, we have a disjoint set, so we put a union. And on the other side, we're going to have 14, comma, infinity. So this will be your answer in interval notation. Okay, so that's your first example. So remember, for both cases, for the greater than or less than, you can you write the original inequality, then you flip the inequality and you change the sign. If it's a negative, if it's a positive, you make it into a negative. Okay? Example 2. So for your next example, okay, the problem says we have the absolute value of x plus 4 greater than 7. Okay, so step 1, you have to, or step 0, isolate the inequality. It's already isolated. There's nothing else on this on the side of this inequality. So we set up our two different inequalities. You have x plus 4 greater than 7, and then you have x plus 4 less than negative 7. All right, so we solved both of those. Here we're going to get x less than negative 11. Here we're going to get x greater than 3. Graph the solution. X less than negative 11, so you have negative 11. We're going to put a parentheses there. And it's less than, so we're going to shape going towards the left. Then we got x greater than 3. So we have 3 greater than means we're going to shape going to the right. Okay, once again, we have a union because we have two disjoint sets that are part of the solution. So the first one, negative infinity, comma, negative 11, union to join the two sets. And then on this side, we got 3, comma, infinity. Okay, and there is your interval notation. All right, a couple more examples. Next example, it's similar, but the additional step here is that we're going to have to isolate the absolute value. So here's what we have. We got the absolute value of 7x minus 3 plus 11, and that is greater than or equal to 29. Okay, so first let's isolate the absolute value, subtract 11 from each side. So we're going to get absolute value of 7x minus 3, that's going to be greater than or equal to 18. Okay? Now, because we have an absolute value, this only happens for absolute value, since absolute value considers the positive and the negative, and both of those represent the distance from 0. So because we have an absolute value, we're going to write our two separate inequalities. We got 7x minus 3 greater than or equal to 18, and over here, we're going to take 7x minus 3, you flip the inequality, and you change the sign. Okay, let's solve both of these. You add 3, so that'll give us 7x less than or equal to negative 15, divide by 7, you get x is less than or equal to negative 15 over 7. On this side, we're going to add 3, so this gives us 7x greater than or equal to 21. You divide by 7, you're going to get x greater than or equal to 3. Okay, so those are our solutions. By now, hopefully you can see that this is a union, but we're going to graph this anyway. So we have negative 15 over 7 on one side, and this time it's a bracket because it's equal to. And then we've got 3 on the other side. We're going to have one solution set going towards negative infinity, one solution set going towards positive infinity. All right, and then in interval notation, you have negative infinity, comma, negative 15 over 7, should be a bracket. Union, because we got two disjoint sets, and then we got 3, comma, infinity going the other way. For our last example, let's practice with the less than. So we got the absolute value of 9x minus 6 minus 8 less than 13. All right, so you start off by isolating the absolute value, which means we are going to add 8 to both sides. Okay, that's always step 0, isolate the inequality. If you do that, we're going to get absolute value of 9x minus 6 less than 21. Now this time, you want the distance from 0 to be less than 21. So that can be like 20, 19, 18. On the other side, it could be like negative 20, negative 19, because all those numbers are less than 21 spaces away from 0. So your two inequalities, you follow the rule, you write the original inequality, and then we're going to flip it, and we're going to flip the sign, or we're going to change the sign. Okay, so let's solve this. You add 6 to each side. This gives us 9x greater than negative 15. You divide by 9, divide by 9, and then that'll tell us that x is greater. Now, if you got to reduce this, so you divide these both by 3, and it'll give you negative 5/3. On the other side, you add 6 to both sides, so we're going to get 9x less than 27. You divide by 9, you divide by 9, and you're going to get x less than 3. Okay, now we got to figure out, is that an intersection or is it a union? So think about what's happening. These x's are getting bigger, but they don't go to infinity because on this side, these x's get smaller. So they're going to meet in the middle. Okay, here's what that looks like. We got negative 5/3, and greater than means we're going to go this way. Now normally it would keep going towards infinity, but that doesn't happen because on the other side we have x less than 3. So it's going to go this way. Now again, x less than 3, it's not going to go towards negative infinity, which it normally does, because we're saying that from here we're getting higher, from here we're getting lower, so we meet in the middle. This is an intersection because the solution set, it meets in the middle. In interval notation, you're going to have negative 5/3 on one side and 3 on the other side. And that is your interval notation. Okay, so take a look at this. If you have any questions, write them down, keep them in your mind, and when you come to class, make sure you ask me.